Hello, everybody. Welcome. My name is Christy Havens. I'm a librarian at the Ypsilanti District Library. This program, Recycling and Me, What's Trash Got to Do with It, is being put on today by some U of M graduate students in plastic engineering. I want to just let you know that we are recording this and we're going to post it on the library's YouTube channel for a month. So if you're not wanting your image to be publicly out there, you might want to click on stop video in the lower left corner on your screen. Also, if you know anybody that wanted to see this presentation and couldn't because of the timing, feel free to tell them about that. So our three presenters have also created a really great PDF document that they sent to me this morning. It talks about how the rules for recycling for Ypsilanti, Ypsilanti Township and Superior Township, and that is available now on the library's events calendar page where you probably got the link to this program. So, and we'll also link to that from YouTube as well. So let me introduce our three presenters: Julie Reland, Shamala Gutanalek, I'm gonna say this wrong, Gunetaleka, and Brian Ayezi. And with that, I turn it over to the three of you.
Okay, so I'll start out. So today our presentation is titled Let's Talk Trash, Recycling in America Today. So in my section, I'm going to be kind of talking like overview and being like, what exactly is recycling? What are some of the dynamics of recycling? And kind of introducing why recycling is kind of a little bit difficult. And then Brian will be taking over. So if we go to the first slide, the first question obviously is why should we even care? Who cares about recycling, right? Well, we should care because plastic pollution or just pollution in general is a huge issue. So this image on the left here is a traditional landfill, and as you can see, it's just taking up large amounts of space, and that stuff that's in there right now, you can see it's a mix of different materials like plastics, wood, cloth materials, and as you can see on the graphic to the right side, you can see that all of these materials have different timelines for degradation, which can range into the hundreds of years. So what that means is that these things that we put into the environment will be there essentially forever. And even when they're degraded, they may not completely degrade. So for example, microplastics is a big thing recently because the plastics that do degrade, they don't degrade completely. They break down into smaller plastic particles that then get ingested into by fish and by other marine animals, and then end up in our food streams and end up in our ingest, like in our food streams as well. Another kind of statistic to kind of visualize how much this pollution is, every 5 minutes we produce enough plastic bottle beverage waste to cover 8 football fields. Thick coverage of 8 football fields every 5 minutes. So this is a huge problem that's happening in our world today. And if you move to the next slide. So what actually happens, so knowing that we have to recycle, knowing that this is something that's important, let's actually learn how this process happens. So the first thing that happens is everyone's seen kind of the green bins or the trash bins, and then they've seen the blue recycling bins. So when you usually what you should do is you should separate your trash and your recycling. And then later on in this presentation, Julie will kind of go into like how do you recycle? Like what can be recycled, what can't be recycled, and when and where certain things can be recycled. But anyway, so you start out with this kind of mixed waste stream. So ideally you should be separating your trash and recycling. And however, sorry, can you go back? It's okay. So, however, as I've shown kind of these arrows over here, sometimes trash ends up in recycling and recycling ends up in trash. When things go into the trash, they end up in the landfills, like I showed in the previous picture, and they either just stay there or they get incinerated. When things end up in recycling, they end up in the materials recovery facility. However, that trash that ends up in there can prove a big problem, as we'll discuss later, with the problem of contamination, where your recycling streams are contaminated with trash, and that causes a big problem when you're trying to sort it out. Another thing about kind of recycling that ends up in the trash, however, is there are these informal economies, which are driven by like canners or people who collect kind of bottles and other things out of the trash when there are like economic incentives, and they actually help recycling by returning recyclables that have ended up in the trash and taking it back to the recycling stream, where then it moves to this thing called materials recovery facility. Next slide. So a materials recovery facility, that's basically where all of this mixed waste, which includes like recycled plastics, recycled cardboard, paper, aluminum cans, all of that kind of ends up in this stream. So it's brought over to this facility where there's a mix of like high tech, but also like manual sorting of the materials. The manual sorting is very important because there can be a lot of contamination, as I talked about before, and that needs to kind of be removed, because if you don't remove it, it can really gunk up all of the streams, and that can lead to suboptimal separation and then suboptimal usage of those separate streams. So this is just like a very broad overview. You can see that kind of the different sections are separated. And then you end up with these kind of individual things of like plastics, cardboard, steel, aluminum, glass. Next slide. So kind of highlighting how high-tech plastics recycling, or just the materials recovery facilities can be in general. They take advantage of a lot of different things. They can take advantage of the density of the materials to separate them. The chemistry, for example, PVC has a different chemistry to the plastics in your milk bottles. So your pipes, plastic has a different plastic to the ones in your milk bottle, and they can use that chemistry to help them in their sorting. You can also use things like the magnetic properties that's used typically separate steel from all the other components in the waste stream, as well as size. So you can break it down and then use that to separate the different materials. So just kind of going over these pictures, they have at the very high-tech areas, you can have like AI-powered visual sorting, optical sorting, non-wrapping screens. So non-wrapping screens, that's to prevent things like plastic bags from getting entangled in their machines, which can typically prove a big problem. So that's one of the things that Julie will talk about later, about how that can be a source of contamination in the waste streams, as well as different types. And then here they also have different types of things like density sorters, and also separating 2D material from 3D material. Next slide. So as I said earlier, you end up with, after you finish all of these processes, you end up with these kind of key 5 streams of material, which is cardboard, paper, steel, aluminum, glass, and plastic. And then in the next slide, I'll kind of be diving a little bit deeper into how these plastics specifically are processed. So why do we care specifically about the plastics? Because they, as I described earlier, tend to be the ones that end up in your environment the longest, and they tend to be some of the harder ones to recycle. And that's why they're kind of the focus of this presentation, because they tend to be the biggest issue when dealing with recycling. We also produce a lot of plastics. Plastics usage, single-use plastic usage has kind of expanded recently, and we're having this kind of boom, but that's leading to this issue of like, what do we do with everything that we're generating? So let's kind of just go over the types of plastics that exist in the world. So just as a kind of a general overview, a plastic is made of this thing called a polymer. A polymer is, but its basic definition is poly and mer, where poly means many and mer means like a unit. So it means many units together. So these polymers are made of many different units that are joined together to form these long chains. So in this image, the kind of chemical structure that you see, that means those lines in the O's or the chlorine molecule that you see there, that represents a mer of the polymer chain. So for example, for PET, polyethylene terephthalate, that mer is that complex structure you see there with the oxygen molecules and kind of that ring-like structure, which is a benzene ring. And they basically, so what that means is that polyethylene terephthalate, or PET bottles, are made of millions of those mers joined together chemically to form these long chains, which can then be processed into different shapes like bottles or cups or different things. So the ones kind of highlighted at the top are the ones that have recycling numbers. So 1 to 6, those are the ones, if you look at your bottle, at the bottom, your whatever, usually if you look at most consumer plastics, they'll have that number. However, and so these are the key ones. You have the PET bottles, HDPE, high density polyethylene, the polyvinyl chloride, PVC, LDPE, you have the polypropylene and the polystyrene. However, that's not all the variety of polymers that exist in this world. Polymers are very diverse, and basically almost everything that you see or have touched today has some kind of polymer or plastic component in it. And these include things like nylon, which is found in your clothing, polycarbonates, which are found in bottles, polyurethane in your bed, acrylic, silicones, polybutadiene, which forms things in your tires. So plastics are all around us. Next slide. So what about the recyclability? As also Julie will kind of jump into a little bit later, not all plastics are recyclable. However, out of the ones that are, which typically are 1, 2, 5, and 6, with some exceptions, of course, but 1, 2, 5, and 6, they're recycled in 2 main forms. The first one is mechanical breakdown and melting. So this is where the plastics that are then sorted at the materials recovery facility are shredded and then broken down into smaller pieces. And they're either used as is if they're lower quality and they can only be used in like padding material or in creating ground material for playgrounds and things like that. Or if it's a slightly higher quality, it can be melted down and pelletized. So like as you see in that picture on the right there. And then those pellets can be remelted and then extruded into different shapes, like remaking some PET bottles or remaking some HDPE bottles. Then you also have this technique of recycling, which is advanced recycling. So that's returning these polymers, so these multiple units, chains, back into their single MERS, so their single units. So basically those single chemical units that you see over there. And this can be done either by something called pyrolysis, where you have no oxygen, so you don't burn the material, rather you kind of high energy break them down into their individual components, and that creates a synthetic crude oil. Or you can do something called gasification, where you kind of convert these molecules into gases, and then that can be used as something called syngas, as another kind of synthetic way of going back to these monomers. Next slide. So however, again, like I was talking, there are some difficulties to plastics recycling. One of the big ones is economic difficulties. Next slide. So in the problem with some of these materials recovery facilities is funding. So materials recovery facilities are not kind of this uniform, like identical thing throughout states and counties. They're very different. Sometimes they can be run by small companies or large companies or municipalities. And as a result, they have different sources of funding and different amounts of funding, and therefore different sources of technology. So all that high-tech stuff I showed is really cool, but it's also very expensive. And the problem with that is that better sorting means purer materials. Pure materials means that the final product, once they finish recycling, is better, and therefore when it's pelletized and reused, it's just a better quality and therefore more desirable. However, if you don't have as much technology, you're going to end up with slightly more impure waste streams. And in addition, that means that things like contamination can pass through. So when I was talking earlier about plastic bags and their issue in the waste streams, so that picture on the right there shows plastic bags kind of gunking up one of the machines that's sorting, and this can take workers like multiple hours to clean out, and that costs time and that costs money. And so because of these variations in technology across different materials recovery facilities, this is why, as you'll kind of see later in the presentation, you have these local variations in recycling. That's why Ann Arbor is different from Ypsilanti, is different from Chicago, is different from New York, because of these variations in kind of funding and the resources they have available. Another issue why the MRF funding is so important is because of the fact that there are low profit margins. And this is driven by factors such as oil prices and the demand for these purified or the kind of sorted recycled goods. So if you move to the next slide, so this infographic kind of shows us that before 2018, there used to be significant shipping of our recycling waste off to China. However, China kind of changed their rules and they increased kind of the limit, or they decreased the limit of contamination that was acceptable in their waste streams, or in the shipped waste streams. And that meant that the US no longer qualified, because actually 1 in 4 of the things that are put into recycling are actually not supposed to be there. So this is a huge issue. And China, which initially kind of like collected all of our waste because they just had this huge economy to take it, just stopped. And so then kind of the US and different countries kind of switched to sending it to other countries like Malaysia, Thailand, Vietnam. But then even they started reducing kind of their intake of some of these materials. And then we've been searching for other countries to kind of ship it to. But this is, because of all of this dynamics, it's led to kind of a decreasing demand, and therefore the prices, the financial feasibility of recycling kind of decreases. And then next slide. So also another kind of economic like factor is the involvement of big oil in recycling. So most synthetic plastics, most single-use plastics that you see today are still made from virgin material. So virgin material means like oil that has been produced from oil refining, like straight out of the ground, not from recycled material. And there's this huge already established industry for this. Big oil and big plastic kind of in the 80s and 90s kind of realized that, okay, landfill issues are becoming a problem. Let's try to kind of maybe address this in some way. And so they did invest in recycling advertising. However, it was very aspirational and was very kind of like, look at this wonderful world that we could have. However, they didn't really invest in the infrastructure of recycling. So we actually have statistics saying that like only 10% of the plastic that's been used in the last 40 years has been recycled. So this is a huge issue because although they're saying, hey, do recycling, it's not actually being implemented physically. And as I kind of went over before, China's manufacturing sector, which used to need all of these plastic materials, now is no longer kind of seeking them out, and therefore it's leading to this kind of lack of demand. Next slide. So going over kind of also how fluctuations in the price of oil can affect recycling. So as you see on the graph on the left-hand side, you can see that towards 2019, there's a price inversion due to a boom in US ethane. And so that actually led to the virgin material being cheaper than the recycled material. And this is a huge problem for recycling because they have these very narrow profit margins. Similarly, if you look at the image on kind of the far right, you can see that in this infographic, virgin material costs less just in general to produce, but also because it doesn't have the additional costs of processing as well as handling and transport. So there's also other limitations of plastic recycling, which aren't just economic, like technological as well. So why did I only say certain numbers of plastics with the recycling symbol were recyclable? So it was like 1, 2, 5, and 6, and it wasn't everything. And that's because, for example, things like PVC, which is number 3, has 56% of its chemical structure made of chlorine. And when you're kind of breaking this down, even if you're physically shredding it, sometimes it can release this chlorine, and the chlorine can interact with different chemicals and form hydrochloric acid, which is number 1, very corrosive and dangerous to inhale and just be in contact with. But it can also damage kind of the processing devices and can lead to kind of issues and unintended costs to those materials recovery facilities. In addition, certain other polymers like the polycarbonates have additives like BPA or other kind of plasticizers which change kind of the flexibility of the polymers. So those things can, when you mix them all together, because this is all mixed waste coming in. So when they come in and it's all these different types of plastics with all these different types of additives, when you try to mix them together, you're going to have this kind of very unexpected property coming out depending on the batch of plastics that you had that day. And this is a huge issue because reliability in the plastics processing is very important. Another issue that we have is something called thermoset versus thermoplastic. So things that can be melted and pelletized and reformed into something are called thermoplastics. But things that can't, so things that like do not melt and will burn before they melt, are things called, or burn rather than melt, are called thermosets. And thermosets are such because, so those long polymer chains I was just discussing, A thermoplastic, they're just kind of just separate, but not chemically entangled. But in the case of a thermoset, there's additional groups linking them, the two chains like this. And so what happens is that to break those chains apart, you have to physically break this bond, and that requires a lot of energy. And so, for example, that means that things like rubber tires cannot be melted and therefore cannot be recycled in those typical mechanisms. Additionally, another issue is that plastics tend to degrade during processing. So those long chains, as they are processed multiple times, can degrade into shorter chains. And for a lot of end product uses, you need an ideal chain length. You need an ideal length of those polymer chains. And if those are degrading over time as you're recycling it, it means that the final product is not going to be as high quality as the initial plastic that it was. Therefore, it can't be recycled indefinitely. And it means that eventually, at some point, it will end up in the landfill or end up being used in lower quality products, which is called downcycling. And then, so the next section will be covered by Brian.
Cool, thanks, Shamali. Yep, I'm gonna go to the next slide. So I'm gonna be covering the economics of recycling. So Shamali kind of touched on why, you know, the oil industry promoted recycling back in the 80s and 90s. And this was taken up as well by our consumer marketplace as well. So when you talk about corporate sustainability goals back in the 80s and 90s, Coke, Pepsi, you know, Nestle Waters all had ambitious recycled content goals because the consumer wanted it, because the consumers saw what was happening with the landfills and they wanted, you know, some solution to it. And so all of these companies set pretty ambitious recycling goals back then, even back then. And this comic here is kind of a joke on how are we going to get to, for example, for Coke, they wanted a 50% recycled content goal. How are we going to get there? And the only answer they could come up with is having 100% of the recycled content from bottle bill states, which I'll go into a little bit more about that in a bit. So essentially, we need to get to like extremely high rates of recycling to actually hit these goals that they kind of touted. And the challenge there is that our recycling rates just aren't there. And so, for example, if you know, Coke, Pepsi, and Nestle all have put out statements within the last year with kind of the increased focus on climate change recently, that they want to have 25 to 50% of all of their bottles have recycled content by 2025 or 2030. So that's for all three of those companies. And our recycling rates would need to be near 70%. And as Shamali said, over the last 40 years, it's been around 10 to 15, maybe 20 tops, depending on the state you're in. And so that's kind of like the math doesn't add up there. And so that's kind of a path forward that we can look at is, okay, so then how could we, like, as a society, could we get to those rates that we need? And so one of the most effective methods is actually having a bottle deposit. So the cool part, I'm from North Carolina, we didn't really have a bottle deposit. And when I moved to Michigan, that was interesting. When, you know, you buy your can of like your 12 pack of Coke, you have to pay an extra deposit on it. And then you can return that for to get some of the money back. And Michigan actually has one of the oldest and most robust recycling, bottle deposit recycling systems. And it's led to much higher rates in Michigan. But like I said, it's only about 10 states right now. So let's say, okay, so if we keep on moving forward, if there's without that financial incentive though, are those rates attainable? So if you go to the next slide. And these are kind of some strategies that could get to those rates without a financial incentive. So the first step is, you know, thinking like talking about education. So how do we minimize contamination and hosting community events like this one to educate people? And then we need to have, like I said, incentives as well, and potentially penalties. And I'll go into the penalties a little bit more in a few slides. So a bottle deposit, for example, is an incentive. So if you buy a can of Coke, like you accept the responsibility as a consumer to bring that back if you want that money back. And then penalties, for example, something like a waste tax, which are implemented pretty widely in Europe. And so that waste tax actually can be applied to both the consumer, but also can be applied to the company making the product as well. So this is getting back to like, how do we, who's pointing fingers at who is responsible for this? And so what they've done, like I said, in Europe, is they've had extended producer responsibility. So these EPRs are where companies are actually responsible financially or physically or both for management of the materials. So what I'm talking about financially, it's like if you're a company, a Coke in Europe, you have to say, I will ensure that all of these bottles will be returned and recycled properly, and provide the funds to do so, versus just putting on their website saying like, we're going to hit this amount, like these rates, but not really having a financial plan to. Or some companies do it physically as well. So like physical pays into the money as well, where like the companies actually institute recycling systems themselves. And so, like I said, the EU has had EPR since about the mid-90s. Another method we can use for increasing recycling efficacy and not putting as much material in landfills is actually have bans on single-use plastic. So as Shmali said, like plastics are useful. Like they have a lot of good engineering qualities, and they've allowed us to achieve a lot of capabilities in our society that we wouldn't otherwise have, but it's also allowed for a lot of convenience, which has led to the waste. And so one area that's been focused on is bags, like plastic bags, because those, the low density polyethylene bags generate a huge amount of waste, because, you get them and then you throw them away almost immediately. And I know Julie's going to talk more about this later, but 8 states currently have bans on single-use plastic bags. Michigan has had some interesting history on this. So I found this article where there's a ban on bans, where there wasn't legislation introduced, I think about 5 years ago, to ban plastic bags at a statewide level. And there was a lot of pushback on that, mostly because what Shmali is talking about is like, there was not really across the board regulation. So even in IPSI, you have to have different recycling for different areas in the same city. So having a statewide ban was kind of thrown out, and then a moratorium was put on it. So a ban on those bans was put. And so finally, like most recently, there's been a ban for having a statewide ban on bans. So AKA, the local municipalities are allowed to decide now. And so that's currently where the legislation is being discussed, is allowing your local cities and counties decide for themselves without having to have a statewide system in place. And that's mostly for practical reasons. I just thought that was kind of interesting, like a local quirk to the bans. So next slide. So this is kind of going into like, when I talk about waste tax, it's something I wasn't very familiar with, and I've learned a little bit more about. And so what does that actually look like? It's something where you either as a municipality, so like you as part of a city, or you as like a household owner on a curbside, have to take more responsibility for your waste, essentially, financially. And so at a municipality level, that could look something like 20 pounds of waste, which would be like, either going to the landfill or going to incineration. You actually have to pay per ton. And typically that money would then go towards increasing recycling capacity infrastructure. But if instead you do a good job of sorting and recycling properly, you could have for example, a subsidy that allows you to decrease your costs, either defray your labor costs or something like that. And these come from a study that I'll go into a little more later, but these are kind of like levels that probably could apply across the US that could help us increase recycling rates. And then curbside, and this is actually something that, yet again, I keep on popping back to like in Europe as well, they have fees where if you generate waste, you have to pay a nominal fee per bag. And so there's an incentive as a consumer to ensure that your waste is properly sorted. And if you have more recycling, you're going to get a subsidy. If you have more waste, you're going to have to pay for it, essentially. And so if you look at the, oh, sorry, last point on the last slide, sorry, is that the tax rates obviously vary. And so like these rates are for in the US, so about 15 cents per bag for landfilling. In the EU, they just, starting January 1st, they actually have to pay about $9 for that same 20-pound bag. So just a comparison to see like where the different rates are. Okay, next slide. So that's kind of like the background on where like the challenges on the economic side of things. So now we're thinking about, okay, so how do we, how can technology help us innovate out of this cycle we're in? So go to the next slide. So actually one benefit to so now, as Shamali said, was when China decided we're not going to take your recycling anymore because it's not clean enough, essentially. And that kind of was like a wake-up call for the American recycling industry, where they had to pretty quickly figure out what we're going to do with all this waste, because the recycling programs didn't end in 2018. Like we still continue to do curbside recycling. We had to figure out where all that's going to go. So the plus side is that has put a lot of incentive on reshoring. We had an added benefit of more investment in domestic recycling infrastructure. So there's been about $4.4 billion in investment in domestic recycling infrastructure over the last 2 years, which has created about 3,000 jobs nationwide, and that's expected to increase. But like I said, the reliance on any one solution can't really solve this problem. So as a consumer, you have to take responsibility for your waste. And you make sure you have to like hold corporations accountable. So the reason I talked about Coke and Pepsi and them is that when they make these goals, there's not really typically no government like oversight. So like they can say any number they want, and that's what happened in the 90s. And then they didn't hit the goals like pretty consistently because there wasn't really anyone holding them accountable. And so as a consumer, we need to be educated and make sure we're holding the corporation accountable. If they're not hitting those goals, we don't buy those products, for example, if this is something you believe in. And then from the manufacturer's perspective, it's been really important that a lot of the companies have stopped setting those really aspirational goals, because on the consumer side, it decreases trust, essentially. And then also making sure they actually invest the funds once they have those attainable goals set. And then the government needs to pass legislation. So like it's already, like I said, started locally. This is an example from, I think this is up in the UP near Marquette. They just built a $6.3 million facility late last year. It's currently in the process of being constructed, and that there is other examples across Michigan that we found. So we go to the next slide. So this is kind of like the exciting, where does innovation, like technology, we're grad students working on technologies all the time. So like, where does the technology potentially help? So I just have a few examples here. I'm going to go into the detail on a few more in the next slides, but how can we take garments that were waste? So like, shirts and pairs of pants that were waste, and how can we convert that into new products that have value versus that are sitting in a landfill and don't have any value? I'll go into, on the next slide, I'll go into more about these shoes. But on the bottom right, this is like an example of a sorting technology that's being looked at that can actually, like Shamali said, chemically sort recyclables at a much higher rate than, either manual sorting or old optical technologies. So if you go to the next slide. So this is a cool kind of business model that a company in Switzerland is looking into, is instead of, and so it's trying to rethink how we think about our products that we use every day, from being a linear model versus a circular model. So you probably will start, as we keep on moving forward in years, companies are trying to switch to like circular models. So a linear model, when you buy something, there's not really any plan for that thing after it's reached its useful life. And that's why we have a lot of the problems with our landfills, is that like you buy something, you use it, and then it's like, oh, what do I do with this thing now? Like, okay, the easiest thing you do with it is put it in a landfill. And so this is thinking about, like, on the design side, how can we change that mindset? And so this company in Switzerland has developed a running shoe that's derived from castor beans. So it's a sustainably sourced material for the plastic that goes into the shoe. But the real innovative thing here is that you're not actually buying that pair of shoes like you typically would. You're actually buying a subscription. So when you buy the pair of shoes, you pay for the subscription service, and then you return that shoe at the end of the life, and they send you a new pair of shoes. And so if you like the shoes, the thought process for like what happens at the end of life is already thought out for you essentially. So that's kind of, there are a lot of companies that are trying to switch over to these models now. And if you go to the next slide, this is a company, I'm like plugging in right now, but my little brother actually works for this startup out in LA, where they are taking mixed fabrics. So textiles in general, like very like currently like almost not recycled at all, because a lot of the problem is because they're blended. So like, the shirt that I'm wearing right now is typically a blend of cotton and polyester. And so polyester is the PET that Shamali was talking about. And when they're blended like that, it's pretty hard to recycle them because it's not a 100% of something, and you can't just shred it and put it in something else. And so what they're looking at is actually using a chemical method where they break down just the polyester from the fabric, and then you get the cotton. So the cotton is usable at the end of it, and then also the polyester is usable. And then they actually just made their first garment about 2 months ago. So this is actually a bike jersey that was made from other garments. So it's from what they know is like the first garment to garment recycled textile. And the reason this is important is because the fashion industry is like a huge polluter. I don't know if you guys have heard of fast fashion, but there's trend recently because fashion has become so cheap, it's become almost single use. And there's a lot of cost, human labor cost, and also environmental cost to creating fashion. And so thinking about ways that we can, create more of a sustainable system within the fashion industry is important as well. So go to the next slide. And then another cool advancements that have come out, they've actually found multiple types of bugs and also enzymes. So like bacterial enzymes break down plastics. And so you could essentially throw all these plastics into a reactor, and the enzymes would essentially eat it and produce a byproduct that would be usable for like further industrial processes. And so then you're really just limited by the amount of enzyme that you can produce. So there's this, in summary, like there is a lot of innovations that are happening in the industry right now to try and address the problems that we have. But Julie's gonna like dive into a little bit more about like how can we like on a local scale really start to make an impact and try and change the narrative on recycling. Oh, we can skip the slide. Yeah, I would take too long to go into it.
Okay, yeah, so now, hi, I'm Julie, and I'm going to jump in on kind of what we can do more on an individual or community level, because listening to a lot of this information, it can feel really overwhelming about what can actually be done on a reasonable time scale, and like how can we individually make impact. And so one of the best things that we can do with like the current state of recycling is to learn more about what is actually happening and on what levels that we can improve things around us. So the first place is to start asking questions. And some of the good questions to ask are, if you're looking at something that you no longer need or has become unusable for its purpose, some of the questions that you might want to ask are like, is this recyclable? Can it go in my curbside bin? How clean does this item need to be before it can actually be recycled? And then other questions like, can I reuse this in some other purpose that it maybe wasn't necessarily intended for? Can it be recycled at a drop-off center if I can't put it in my curbside bin? And I guess I did a duplicate. What are other ways that we can reuse these items? So diving into these questions on the left side about what is recyclable and what do I need to do before this can be recycled? We come to this question of contamination and what it looks like. And so earlier in the presentation, Shamali gave a really good explanation of what a lot of this contamination looks like and what makes it not usable. But let's take another look at that on more of an individual level. So like what Shamali said, our recyclable plastics are usually denoted by these numbers on the bottom of the containers. So like on pop bottles, we'll see 1, and on milk cartons, like the plastic jugs, they're usually 2, which is polyethylene, which is the same material that plastic bags are made out of, but a slightly different chemical structure that makes it so that the milk bottle is solid and like hard to the touch, and the plastic bag is soft and crinkly. The question is, even though they put these recycling symbols on them, are they actually recyclable? And that is really going to depend on your local municipality or whoever, whatever company is doing the recycling for you in your area. And what that comes down to is that you really need to look up what your local recycling department does, because it looks different from each place. And for all of you in the Ypsi library footprint, so coming out of the township of Ypsilanti, the city of Ypsilanti, and Superior Township, there's some pretty significant differences between what each one of your areas can actually throw in the curbside bin. And I have pulled together a easy handout for you that is currently available on the library website, and it sounds like will be also linked with the YouTube video later, but I'd recommend you taking a look. It's very interesting to see what is recyclable in certain areas. So generally speaking, these materials are pretty safe depending from location to location. PET is really standardly recycled. High density polyethylene is recyclable. Cans, most junk mail, aluminum cans, and like yogurt containers. And then polystyrene becomes a little bit of an interesting question. So you might be surprised to know that solo cups, and if anyone remembers CDs and the clamshells that you put CDs in, those are typically made out of polystyrene, the same material that styrofoam is made out of. So many recycling areas will take these they're called extruded polystyrene, but most areas can't take styrofoam, and we'll get into that a bit later. So coming to that question of what is recyclable and the thought of what looks recyclable is really comes down to that question of what your local provider takes, but can introduce a huge problem if the expectations from the recycling provider are not met by the people who are doing curbside recycling. So one of those big problems that really plays into contamination is this concept of aspirational recycling, which is really produced by this kind of personal desire for something to be recycled, but it's not actually recyclable. So this hope to be helpful and good for the environment can cause problems in the long run. And some of those areas where these aspirational recycling kick in are with styrofoam, things like receipts, plastic bags, and batteries, which are actually flammable. And earlier in the pandemic times, there was actually a flaming flaming garbage truck just down the street from me that was putting out a bunch of smoke, probably because someone put like batteries in their garbage. But it ultimately worked out, but it was kind of smelly in the neighborhood for a while. some of the reasons that these aren't recyclable is because styrofoam is very lightweight. So it can actually cause a huge environmental problem when people put recycling into the recycling bins, because when the trucks are driving down the road, packing peanuts in styrofoam cups can really easily fly out the back of the truck and cause local pollution. And if they make it all the way to the recycling facility, they're actually so light that it'll often fly off the sorters that are used to calculate, separate the recyclables. And so it really just becomes trash and junk on the ground at the recycling facilities. And it's not economically worth their time to sort and pick up all of this styrofoam that comes in. So it just becomes garbage that has to be brushed up later after all is said and done. And then receipts are a mixture of plastic and paper. So this can't be recycled as either plastic or paper, kind of like what Brian was talking about with that garment recycling. And so that also becomes a problem in the aspirational recycling. And I know that I'm guilty of throwing receipts in the recycling bin. So that's something that I'm working on remembering to actually put in the trash where it belongs. So a really cool thing that is offered is that though some things aren't recyclable in your curbside recycling, you can sometimes bring them to recycling drop-offs. And these often have a more extensive list of materials that they accept. For instance, like tires and concrete and larger wood and large scrap metal, which are some of the more attractive recyclable materials cost-wise, but aren't necessarily easy to deal with in curbside drop-off. So this is a really great way you can reduce your own footprint on some materials that are technically recyclable but can't be put in the curbside drop-off. As well, this is a diagram from Recycle Ann Arbor, which has an agreement with, I believe, the city of Ypsilanti, and allows city of Ypsilanti residents to get tags so that they can drop materials off at the Recycle Ann Arbor Center at either free or a reduced cost. There's more information on this in the handout as well that can be found on the library website. Yeah, here. So there's an extensive list of what can be recycled, and they have pretty okay hours that range from to kind of after the workday on weekdays, as well as some weekend times. And it's sometimes nice to come in and see like what kind of impact are our local businesses and like recycling centers having on like the global like climate change and global warming. And just in the Recycle Ann Arbor alone, which does Ann Arbor side curbside recycling, as well as the drop-off center. And they previously had a thrift store that was really awesome until it closed during the pandemic recently. But they recycled 13,000 tons of material in 2019 alone. So these these businesses can have incredible results when they are run efficiently. Let's see, we have to run through quick. So next, coming to the question of how clean do recyclables need to be, and what kind of contamination can come from just interactions with food. So one of the main goals, like a good borderline, is to have no visible food or grease on your paper or plastic recyclables. So like these ketchup condiment bottles would need to be rinsed out before they could be recycled. And unfortunately, pizza boxes generally aren't accepted because this grease will contaminate the paper recycling line. I sometimes, if the top of the box is clean, will cut this top box off and recycle it if you're feeling motivated. But these are some of the rules that are helped to keep the contamination down so that we can produce better recycled materials on the other end and produce higher value. So like I said, like greasy pizza boxes and other greasy food containers, like especially if you have an empty container that had vegetable oil in it, that should be really well washed with soap and water until you can't see any grease, or it would be better to put it in the trash if you don't have the time or the energy to completely clean out such greasy containers. However, pizza boxes are compostable. So if you have a municipal compost bin, you could put a greasy pizza box in there. The question of why this grease acts as a contaminant is because, chemically speaking, something like vegetable oil right here is very chemically similar to a lot of the plastics that are recyclable. So like this top chemistry is for polypropylene, which is a material that is commonly used to make like yogurt cups and the screw top lids on like Coke bottles. So this string of C's, which are the carbons, is really similar to the string of C's on the vegetable oil. And so when you melt the plastic down to the liquid form, it becomes almost impossible to separate the vegetable oil molecules from the plastic molecules, and it can really junk up the plastic products, so it won't be able to be reused in other plastic products. The other thing that to keep in mind is that there's a huge human element in the recycling line. And it's just really gross to interact with people's used food stuff. So it's also the polite thing to do to try and keep the recycling bins clean and not full of trash, which is because these people are doing really hard and good work, and I think it's nicer to give them a cleaner thing to work with. So some of the things that we can do with with recycling is remembering that there's actually several steps before you get to recycling on what is this priority of how to dispose of a material. And so when you take this approach of like buying something new or using any kind of material, there's like a mental checklist that you can go through that targets this reduce and the reuse before even getting to the recycling point. Because especially with the state of recycling in the United States as it is right now, there are quite a few options that are better than recycling. For instance, using reusable products like water bottles or plastic bags, or right now using like fabric masks that are reusable, and also reducing like consumption. Like you can refuse straws at stores, or mend your clothes so you don't have to buy clothes as often, or even things like going for paperless billing so that it reduces how much paper and junk mail you receive, can all really target these reduce and reuse functions before we even get to a point where we need to recycle, which can overall reduce our waste footprint and our environmental footprint. So, and then the last thing I want to leave you with is this idea of educating and advocating. So the current state of recycling in the United States might seem a little bit bleak, but there's still a lot that we can do in the meantime to help get these streams of recycling into a better place, so that when we have the infrastructure to meet it, we're really ready to make great recyclable products on the other side. And helping to educate those around us to kind of take this proper approach to disposing of materials. And then we can advocate. So as consumers, we can push companies to use more recycled product in their lines, and to be better with recapturing the waste that they do produce from their products, and also creating products that have less waste in the start. And then we can also push for elected officials who will take this as an issue that they see as something important to approach in their term of office. And lastly, we can vote with our dollars as consumers and buy materials that are made with recycled goods already, because there are already quite a few materials in stores that we can purchase that have recycled goods, and showing that these are desirable materials can go a long way to really helping the system. And a lot of research went into this presentation, and if there's interest, we could pull out those references as another document. But thank you so much for listening, and we have about 4 minutes for questions, so it's a little bit short, but if there's any questions, I'd love to hear them.
I have a question, a couple of questions. I was going to ask this.
Oh, we lost you.
Yeah, sorry, my elbow hit the mute button over on the right here. I don't know how that happened, but so I was going to ask this in terms of receipts, and that receipts often have BPA in them, and I've wondered what happens if you are recycling receipts and then you buy recycled paper products in the store. Does it have BPA in it? But I guess we're not supposed to be recycling receipts. So I guess the question could go to bottles. So if some bottles have BPA or any other toxic chemical, and those are recycled, I mean, are people paying attention to that? The manufacturers, are they making sure they're not recycling toxic chemicals into their recycled products, or what? How is that working?
So that becomes kind of a hard question. So most plastics are going to have a whole slew of additives, whether it's to make it so that it's like a flexible material, because most plastics are really stiff, and they put things like phthalates and BPA to actually partially dissolve it in the solid state so that it becomes something flexible and not like something that'll shatter if you drop it. So these materials are present, and they often will off gas or be separated out when they're reprocessing the recycled material. So it is something to keep in mind, and there is something to say about the health costs of using any plastic in general in relation to food or microwaving food in soft plastics. But it's something accounted for in the recycling process, because they're probably just going to add them in again on the other side, if that answers your question.
Thanks. I have another question if nobody else has one. Brian, you were talking about states that have bottle deposits, and Michigan being one of 10, which is shocking to me, I guess, because I grew up in Michigan. I just assumed everybody has that, and they don't, apparently. Do states that don't have bottle recycling law, bottle deposit laws, are they recycling bottles anywhere near the amount that states that have them do, or not?
In all the references slides that we put up, there's I could point out, I'll try and send which ones there that cover this, but generally no. The financial incentive is pretty strong, and that's why there is a lot of legislation in states that don't currently have bottle deposits to, I think the number I saw was like, there's like 250 bills in like all of those 40 other states that are currently looking at doing something like this, because they've been shown to be effective. But they're not like I said, like an end all be all, because in some other ways, Michigan hasn't been recycling other products as well. So like on the bottles, I think they've like done a good job, but I think in some other respects, there have been other parts where there haven't been, as you know, like at the rates you need. In the slide I skipped, there is some trade-off as well, because there's a burden on the consumer as well, because that's interesting. They looked at like the social cost, which is you have to like work to get that money back as well. So there's like kind of a trade-off as well, where how much work are you willing to put in to get that 10 cents? And I think that's why some states are looking at moving from 5 cents to 10 cents as well, because the 5-cent incentive might not be enough. So,
Go ahead.
I'm not sure if this is appropriate, but I read an article not too long ago about some recycling that they've been doing in, I think, somewhere in South Florida, and they built this state-of-the-art recycling center, and it's supposed to have done wonders to reduce all the pollution numbers. Do you know anything about it?
I personally,
Sorry.
I haven't heard anything about it.
Okay, okay. I just wondered because I've been thinking about that, and I thought that might be something to present to our cities. You know, I'm sure it's going to be pricey in the beginning, but they may be able to swing it in the long run. So anyway, I'll go dig it up and be a little more informative when I talk.
Yeah, that sounds great. Thank you.
Mm-hmm.
Yeah, but it is very interesting how different kind of this piecemeal thing across different states, because some states are doing some things really well and then some things really badly. And it leads to like a lot of issues because there's no standardization whatsoever. Some areas are very rich and therefore can afford, you know, the best supplies, and then some areas have nothing provided to them and then they can't, you know, carry out recycling. So there's a very uneven kind of distribution of recycling power and recycling ability. Like even kind of the discussion of bringing materials to the recycling, like the bottle deposit is great, but I actually am facing kind of one of these issues because under my kitchen sink I have this huge collection of like glass bottles, but I don't own a car. So for me to take all of those glass bottles back means that I have to lug all of them in my backpack back to Kroger, and that's really hard for me because it's a lot of weight and it's a lot of bottles. So kind of dealing with those kinds of things and accessibility issues for different people is something that governments or local state governments are not dealing with as well as they probably could be right now.
I agree.
One thing that we also didn't cover is that the coronavirus pandemic has taken a pretty serious toll on where we were with recycling beforehand, like before all of this, because it's such a hands-on process.
Set them down.
There's been a, wow, okay, I'm trying to find something. So actually earlier this year, I wrote a news article on how COVID has been affecting recycling. I'm trying to get to the news article and it's being stubborn about actually getting to the article. But something that we've found is that a lot of curbside recycling has ended, like they just canceled it in places because there wasn't the safety of the workforce at the recycling facility to actually process the recyclables once they were brought in, and then also to just the sheer volume of waste material that was being produced at the beginning of the especially like in quarantine times when we were all at home and producing all of our waste at home as opposed to distributing it between like being at work or just being out at restaurants or stores. So there was a really big added stress to the system in the last, how long have we been in this? 7-8 months. And so that's another consideration. Where are we at? So it looks like we're about 5 minutes over time. Is there any other questions?
No, you guys did a great job. I really appreciate the information. It's very interesting as well.
Yeah, thank you so much.
Thank you. Thank you. You guys put in a lot of work, obviously. This was really great, very informative. I hope people go to our YouTube page and watch this over the next month. It's really been helpful. Thanks so much.
Thank you.
Thank you all. This is fun.
Yeah, thank you.
You're welcome. Maybe you should take your presentation to city councils, at least Ann Arbor and Ypsilanti, because they're close.
Mm.
Maybe they're not as well informed.
Mm.
Yeah, I think that would be something to look into. Thank you for the recommendation.
Sure.
Hey, I think we're all set. Thank you all so much.
Yep.
Good. Thank you guys.
Thank you.
Bye.
Bye.
Bye-bye.